we just got done graphing logarithmic functions and converting between logarithmic and exponential functions. Now we're going to focus on solving logarithmic and exponential functions. So we're still going to be converting between log form and exponent form, and then from exponent form to log form. So today we're going to focus on solving logarithmic equations first. So we're going to be converting from the log form that's given to us to exponential form. So let's start by setting these two equations here equal to each other, because remember, that's how you solve a system. You can set them equal to each other. So we're going to do log base 3 of x plus 5 equals 2. So the first thing we're going to do is we're going to convert to exponent form. So you might notice that some of these steps are the same as the steps we took when we were trying to find inverses. So when I do that, my base is 3. The word log and the exponent are on opposite sides of the equation. So my exponent is 2. And that's going to equal this stuff on the inside here. There we go. X, I used purple already too. Let's use pink. X plus 5. All right, now that is something that we can solve. 3 to the second power, or 3 squared, is 9. And that will equal x plus 5. And then we will subtract 5 from both sides, and 4 is equal to x. Now, we do need to plug in x to the log. To see if we get a negative answer or a negative number. Because we can't take the log of a negative number, just like how we couldn't take the square root of a negative number. So you don't need to use the log part. We're just looking at this part right here, the stuff inside the log. So if I plug in x equals 4, I get 4 plus 5, which is 9. That's a positive answer. So we know we're good to go. If we would have gotten a negative answer, then we know that there was no solution to that equation. All right, now let's look at example number 2 down here. Our base is 4. Our exponent is 5. And that will equal the other stuff here, 10x plus 624. So if I get my calculator out and I type in 4 to the 5th power, I get 1024. That equals 10x plus 624. Then we will need to subtract 624 from both sides because we need to get x alone. That will give me 400 equals 10x. And we'll divide both sides by 10. And we get 40 is equal to x. So again, we'll take that value and plug it in just inside the log part. It doesn't really matter what that equals, like what number you get, as long as it is positive. So 10 times 40 equals, or plus 624, and that equals 1024, which is a positive number. So we know that this is our solution. Now in letter B, we have some stuff going on. First, we have this 1 just hanging out there, not next to the log. We have this negative 2 in front of our log. And remember, ln is log base e. So we have a lot going on. Let's get the ln by itself first. So we're going to subtract 1 from both sides. Okay. So that's going to give us negative 2 ln of x equals negative 5. Then we have to deal with this negative 2 in front of the ln. So we'll divide both sides by negative 2. That gives us the ln of x equals positive 2.5. Well, now that we have the ln all by itself, or the natural log by itself, we're going to change this to log base e, just like what we would have done before when trying to find the inverse. So log base e of x equals 2.5. So e is our base, our exponent is 2.5, and that equals x. So now in the calculator, I'm going to type in e raised to the 2.5 power. And remember, if you've forgotten where to do that, second and the ln button automatically puts e raised to a power, so 2.5, and we get 12.18. Now we need to plug that back in. Well, look up here. All we have is just x. It's not x plus something, it's not x minus something. So when I plug that in, it's just going to be whatever value we have here, 12.18. It doesn't matter that it equals a negative number. All that matters is that when I plug in x, I don't have a negative value inside my log. That's the only thing that matters. So this will be our answer. All right, so let's look at the next page. All right, so in our next page, you see that we don't have anything attached to the log. We don't have a number in front being multiplied, and we don't have like a plus or minus or anything in the front. So we can convert this to exponential form right away. So we have 3 raised to the 3rd power is going to equal x squared plus 6x. Okay, us having this x squared right here means that this is a quadratic function. So we need to get everything on one side of the equation. 3 to the 3rd power is 27. So we're going to subtract 27 from both sides. So 0 equals x squared plus 6x minus 27. So now we have to factor this. And remember, when we factor, we want two numbers that multiply to negative 27 times 1, so just negative 27, and add up to positive 6. So two numbers that add up to 6 but multiply to negative 27 are positive 9 and negative 3. So this factored form will look like this. And you should remember that our answers, or our zeros, will be x equals negative 9 and x equals 3. Now we need to check both of these, and just because we have x equals negative 9 doesn't automatically mean that negative 9 is not a solution. So I'm going to plug in negative 9 squared plus 6 times negative 9. And when I type that into the calculator, I'm going to get positive 27. Okay, so that one works. And if I do the same thing for positive 3, if I type that into the calculator, I get positive 27 as well. So x equals 3 is a solution. All right, now letter D. Again, we don't have a number in front, So we don't have to multiply both sides by anything. We don't have anything being added or subtracted. So we can convert this right to exponential form. But wait a minute, we don't have a base. Remember, if we don't have a base, that's an invisible 10. So 10 raised to the second power equals x squared minus 15x. Well, 10 squared is 100. So 100 equals x squared minus 15x. We'll then subtract 100 because just like the previous problem, this is a quadratic. So we need to get everything to one side. Now we can factor this, x squared plus 15x minus 100. And we need two numbers that multiply to negative 100, because the invisible 1 times negative 100 is negative 100. But also those two numbers must add up to positive 15. So those two numbers are going to be negative 20 and positive 5. So then we'll get 0 equals x minus 20 times x plus 5. So we get x equals 20. X equals negative 5. So then we can plug those in. 20, and when I say plug them in, remember, I mean plug them into just that part right there. So 20 squared minus 15 times 20. If I type that in the calculator, that gives me 100. So that checks out. Then I will type in negative 5 squared minus 15 times negative 5. If I type that in the calculator, that will also give me 100. So that checks out. So both of these solutions work. Now these last two here, I want you to pause the video and try. Notice that both of these have a number in front. So you'll have to divide both sides by that number in front first before you convert this from a log to exponent. So pause the video. When you get your answers, unpause it to see if we get the same thing. All right, so here's the answers plus the work shown. Like I said, you had to divide both sides by the number in front. So hopefully you got these answers, and hopefully you're realizing that you really need to know how to go from log form to exponential form. Not knowing how to do that is going to really put you at a disadvantage when working with these problems. And now tomorrow we will go from exponential form to log form to solve exponential equations. So hopefully this wasn't too terrible. The steps were pretty rigid. Getting the log by itself first, like we did this last two. We got the log by itself by dividing by 3 or dividing by 4, then converting from log to exponent form, and then solving it, and then making sure you plug in your answer to see that your answer makes sense. So thanks for watching. Make sure to like this video and subscribe.